Hi everyone! Our objectives for today are that students will be able to use arithmetic sequences and find the sums of arithmetic series. Let's get started. Alright, so first of all, what is an arithmetic sequence? The formal definition of an arithmetic sequence is a sequence in which the difference between any two terms is constant. So an arithmetic sequence is a sequence in which the difference between any two terms is constant. Now, this difference that we're talking about, we call the common difference. The common difference is the numerical difference between the two numbers, and it's represented with the variable d. So that number, so what we do is we say the second term minus the first term, whatever that difference is, and it has to be a common difference between every term. That is our common difference. And an arithmetic sequence always has a common difference. So make sure you have these two definitions written down. If you need to pause your video, go ahead and pause it. Otherwise, let's move on. All right, so in order for a sequence to be an arithmetic sequence, it has to have a common difference. So what we want to do is look at this sequence and determine, or this series, right? Because it goes on forever. Well, series is when we want to add it together. That's the sum. So we would call this a sequence because we're not trying to add it up. All right. So our arithmetic sequence, is it arithmetic, needs to have a common difference. If it is, we want to identify that common difference and use the variable d and give the next three terms. All right, so what we want to do is take the second term, subtract the first term. That's our common difference. All right, so we know that we're adding 3 to get to the second term. All right, or just recognize that you're adding 3 to get to the next term. To go from 8 to 11, we're adding 3. To go from 11 to 14, you're adding 3. To go from 14 to 17, you're adding 3. So this sequence has a common difference. The difference is 3. We're adding 3 to every term to get the next term. This makes it an arithmetic sequence. So yes, this is an arithmetic sequence, and our common difference is 3. The next three terms would just be add 3 to 17, we get 20. Add 3 to 20, we get 23. Add 3 to 23, and we get 26. There's our next three terms. All right, so number 3, let's look for that common difference. So to go from 1 to 2, we're adding 1. All right, and it always has to be addition or subtraction here. We're not dealing with multiplication. With arithmetic sequences, it's a common difference, meaning adding or subtracting. All right, so we always have to add or subtract something to get to the next term. So to go from 2 to 3, we add 1. To go from 3 to 5, we add 2. Ooh, and to go from 5 to 8, we add 3. These are not all the same. It is not a common difference. It's not the same difference between every term. We've got 1, 1, 2, and 3. Not a common difference. So no, this is not an arithmetic sequence. All right, number 5. To go from negative 20 to negative 10, we're adding 10. To go from negative 10 to negative 5, we're adding 5. Negative 5 to 0, we're adding 5. And from 0 to 5, we're adding 5. So this first part right here where we're adding 10 ruins it for us, all right? It is not a common difference. We're not adding 5 every time. We have to add the same thing to every term in order for it to be an arithmetic sequence. So no, this is not an arithmetic sequence either. All right, the cool thing about arithmetic sequences is that we have a formula to find the nth term. So this is a formula we need to memorize. This is a formula we need to know. An arithmetic sequence, in order to find the nth term of any arithmetic sequence, we can use this formula. So we say the nth term equals the common difference times the term number minus 1 plus the first term. All right, so a sub n equals d times n minus 1 plus a sub 1, where a sub 1 is the first term all right? And D is the common difference. All right, so this formula right here is very important. Anytime we're dealing with arithmetic sequences, we need to know this formula. That'll help us find the nth term of any arithmetic sequence. All right, so number 7, our directions are to write a rule for each sequence and find the indicated term. All right, so we know that it is an arithmetic sequence because we can see that it's increasing by 4 every time. It has a common difference. All right, we're adding 4 to the previous term to get the next term. Adding 4. Adding 4. So that tells us that yes, it is an arithmetic sequence. So yes, we can use this formula we just learned. All right, so we first need to identify our common difference. So D equals 4. We need to know our first term, so A sub 1, or our first term, is -5. And now we can write a rule for this sequence. All we need is the common difference in the first term. So we say A sub n equals our common difference, which we know is 4, times n minus 1, plus our first term, which we know is -5. Then we just want to simplify this out, all right, so that it looks more like a linear function. So we would say 4n minus 4, we distribute, minus 5, combine these like terms, so we get A sub n equals 4n minus 9. And there's our rule. Now, so this is our first part, write a rule for each sequence, check. Now we want to find the indicated term, and the indicated term is we're looking for the 24th term. So what we're doing is plugging 24 in for n. So the 24th term, or A sub 24, equals 4 times n, which we know is 24 if we're looking for the 24th term, minus 9. All right, plug that into your calculator, 4 times 24 minus 9, and we get 87. So the 24th term is 87, and you're done. You've got your rule and your 24th term, your indicated term. All right, so number 9. Now number 9 is decreasing. All right, we've got a sequence, but it's decreasing by 3 every time. So to go from the first term to the next term, we're subtracting 3. To go from the second term to the third term, we're subtracting 3. To go from -12 to -15, we're subtracting 3. So what this means is that our D, or our common difference, is just negative. So D equals -3. That just means our common difference is that we're subtracting 3 every time. All right? It's going down by 3 every time. Now we need our first term. A sub 1 is -6. Now we're going to use that formula we know. We know A sub n equals common difference times n minus 1 plus the first term. All right, we're going to plug this information that we know into this formula to get our rule. So we say A sub n equals our common difference, which is -3, times n minus 1, we don't know what n is, plus our first term, which is -6. Now we're just simplifying. Distribute the -3, subtract 6. We get that A sub n equals -3n minus 3. And there's our rule for the sequence. Now, we need to find the 38th term, so we plug in 38 for n. So A sub 38, or the 38th term, equals -3 times 38. We're just plugging 38 in for n, minus 3. Plug this into your calculator, -3 times 38 minus 3, and we get -117. So we've got our rule right here, and we've got our 38th term, -117, and we're done. All right, now you can see a problem like number 11, where our directions are that we're given terms that are part of an arithmetic sequence. So we're given that these terms are in fact part of an arithmetic sequence. And we want to write a rule for their sequence, then find the 12th term. All right, so we're given the first term and the third term. In order to write a rule, we need the first term and our common difference. So we're going to use these two terms to find our D, to find our common difference. We're going to start with our formula, all right? We know our formula for an arithmetic sequence is A sub n equals D times n minus 1 plus the first term, all right? Now plug in what we know, all right? We know we're going to be using A sub 3, our third term. We don't know our common difference. If we're using our third term, that means n equals 3, so 3 minus 1. And we're going to be using our first term as well. Now plug these numbers in. So we plug negative 7 in for third term, or A sub 3, plug in 3 for A sub 1. Copy everything else down. Now it's just an algebraic equation and we're solving for D. So negative 7 equals 2D plus 3. Subtract 3 from both sides. Divide by 2. All right, and our common difference is negative 5. So we've got our D. Now we've got our D and our A sub 1. We've got our first term and our common difference. Now we want to go back to our formula and plug it in to find our rule. So A sub n equals our common difference times n minus 1 plus our first term, which is 3. Simplify, so we get negative 5n plus 5 plus 3. So our rule is A sub n equals negative 5n plus 8. There's our rule. Now, our goal is to find the 12th term as well. All right, that's in the directions. Once we find the rule for the sequence, then find 12th term, or A sub 12. So A sub 12 equals negative 5, n equals 12. We're just plugging 12 in for n, plus 8. Negative 60 plus 8. So A sub 12 equals negative 52. And we're done. All right, now let's talk about arithmetic series. So I want you to recall that a series is just the sum of a sequence. All right, I think I mentioned it at the very beginning of this video. All right, so a series is just when we add together all the terms of a sequence. It's the sum of a sequence. And when we're finding the sum of an arithmetic sequence, we can use the following formula. We've got a special formula for the sum of an arithmetic series. So we say that the sum, all right, the partial sum, so S sub n equals n times the first term plus the nth term divided by 2. All right, where n is the number of terms, A sub 1 is the first term, and A sub n is the last term. All right, so here's one more formula we need to know. All right, so number 13, we've got an arithmetic series, and we want to find the sum of the first 10 terms. That's what S sub 10 means. We want to find the sum of the first 10 terms. So automatically we know we're going to be using this formula right here, and we know that S sub 10 means that n equals 10. We already know our first term equals 2 just by looking at our series. We see that our series starts with 2, so our first term is 2. Now we need to find the nth term, and in this case, we need to find the 10th term. So in order to find the 10th term, we need to use our rule for finding the 10th term. So A sub 10 equals our common difference, and we see that we're adding 2 every time, so our common difference is 2 times n minus 1 plus our first term. All right, so we get 2 times 9 plus 2, 18 plus 2 gives us 20. all right? So a sub 10 equals 20. These are the three pieces that we need to know. Now we're plugging them into this formula to find the sum of the first 10 terms of this arithmetic series. So the sum of the first 10 terms equals n, which is 10, times the first term, which is 2, plus the 10th term, which we found out to be 20, divided by 2, equals 10 times 22 divided by 2 equals 10 times 11. So the sum of the first 10 terms equals 110. All right, much easier than what we did last class where we expanded it out and then added it all together. Now we've got a rule to help us find it. Makes life so much easier. All right. Now, what happens when they're written in summation notation? All right, so we know we're going to be using the formula we just learned. All right, we want to find the sum. So S sub n equals n times a sub 1 plus a sub n divided by 2. All right, that's the formula we're going to be using. Now, we need to know what is our n, what is our first term, and we want to know whatever a sub n is. So we first need to find n. What is that term? Okay, we need to know our a sub n term. So first things first, how do we find n? So in order to find n, we want to look at our summation notation, and we want to look at the first term and the last term. So in order to find n, we want to take the last term, subtract the first term, and then add 1. All right, so n always equals the top 12 minus 1 plus 1. All right, so 12 minus 1 gives us, we subtract it, we get 11, add 1, and you get 12. All right, and the reason why this is this way, all right, we can't just do 12 minus 1, get n equals 11. Because what I want you to do is I want you to sit here right now and count on your fingers, all right? If our first term is 1, that's one finger, put your thumb up. Second term is 2, put another finger up. Then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 terms, all right? So as a general rule, what we do, we don't want to sit here counting on our fingers all the time. We subtract them, add 1, and that gives us our n. All right, so we know that n equals 12. That means we're going to be looking for a sub 12, all right, and we want a sub 1. So in order to find a sub 1, what we're doing is we're plugging 1 in for x, okay? So in order to find a sub 1, we're saying 6 times 1 minus 4. That gives us 2. So a sub 1 is 2. In order to find a sub 12, we're saying 6 times 12 minus 4. All right, 6 times 12 minus 4 gives us 68. All right. So a sub 12 equals 68. Now we got the pieces of information we need, and we just plug it into our formula. All right. So I know you guys can't do this, and you always get frustrated with me because I just scoot everything up when I run out of space. I apologize. All right, go off to the side if you need it. Now we're plugging it into the formula. So the sum of the first 12 terms, all right, equals, we say n is 12 times our first term is 2 plus our 12th term is 68 divided by 2. So 12 times 70 divided by 2, we get 12 times 35. Plug that into our calculator, and the sum of the first 12 terms, 12 times 35, gives us 420. All right, and that is our final answer. All right, the last example we're going to do today is number 16, and the reason I want to do number 16 with you, I know it's an even, and we normally don't do evens, but it looks a little different than number 15, and I want to be sure to do one of these with you, where m does not equal 1, m equals 8. All right, so we're going from the 8th term to the 17th term. Our first term is when m equals 8, our last term is when m equals 17. Now, this is when it's really important for us to find m, or to find our n, right? And we want to do n equals 17 minus 8, then add 1, all right? So n equals 17 minus 8 plus 1 more, all right? And if you were to count on your fingers from 8 all the way to 17, you would get this same answer, right? 17 minus 8 gives you 9, add 1 and you get 10. All right, so n here equals 10. Now, we're going to use our formula for summation, all right, for the sum of an arithmetic sequence. So the sum equals n times the first term plus the nth term divided by 2. Now we've got that n equals 10. And we need our first term, and our first term, all right, a sub 1 is going to be when m equals 8. So what we do is we say negative 2 times 8 plus 3. And our last term, or a sub n, all right, our last term, or in this case our 10th term, is going to be when m equals 17. So we say negative 2 times 17 plus 3. All right, so going back to our first term, negative 2 times 8 plus 3 gives us negative 13. That's our first term. Our 10th term, or our last term, when m equals 17, is going to give us negative 31. All right, so these are the values we want to plug into our formula. So now we're using this formula, plugging in our n equals 10, our first term, and our last term. So the sum of this series is n is 10, 10 times first term is negative 13, plus last term is negative 31, divided by 2. All right, then we're just simplifying. We've got 10 times, let's see, we got negative 44 divided by 2. That gives us 10 times negative 22 equals negative 220. And that's our final answer. All right, I hope you learned a thing or two about arithmetic series and sequences today. If you have any questions, raise your hand, call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day.